Hello my students, how are you? Prep 2. Today we'll explain from students book, lesson number 2, unit 3, in geometry. This lesson talk about inequality in triangles. We studied before the inequality between two sides in triangle, and we can find the relation between the remainder and also the relation between two angles. Now we will talk about inequality in triangles. Like that, if we have two sides equivalent in triangle, this triangle we call it isosceles. And also if we have two sides are different in the lengths, in the opposite of greater lengths, it will be greater in the angles. Like this triangle, we have here 27 meter, 27 meters, then measure of angle C is greater than measure of angle B, which angle B opposite length 24 and 21 opposite angle A. Then the order about the measure of angles descending from greatest to smallest, measure of angle C greater than measure of angle B greater than measure of angle A, because 27 greater than 24 and 24 greater than 21. Look at the theorem. If two sides of triangle are equal in length, then the longer side is opposite an angle that is greater in measure than the angle opposite the other side. Like EP was greater than EC, then the measure of angle C is greater than measure of angle B, because angle C opposite to angle B. Then if two sides of triangle are unequal in length, then the longer side is opposite an angle that is greater in measure than the angle opposite the other side. And also look at this triangle, we have EP here, or EC equal to 80. We have isosceles triangle, then EP will be greater than EC, because EB such that BA subset from it. The length BA subset from the length BA, then BA greater than EC. So measure of angle C will be greater than measure of angle B in this triangle ABC. Listen about example like this. For the example, the given figure, measure of angle B greater than measure of angle A. B greater than angle A, because AC greater than BC. And also measure of angle A is greater than measure of angle C, because BC greater than BA. That's the meaning we can write the order: measure of angle B greater than measure of angle A greater than measure of angle C. Converse of the theorem. We now talk about the angles, the relation between two angles. If two angles in triangle are unequal in measure, then the greater angle in measure is opposite the longer side than the side opposite the other angle. What's the meaning? If measure of angle B greater than measure of angle C, then the opposite side of B is C greater than the opposite side of CAB, then EC greater than AB. Look at here. We can write the order about the sides here. We have 70 greater than 60 greater than 50. Then BT greater than ST greater than SP. You can write the order. For example, number 1 proves that it is required to blue each figure. You can read this example. We have two alternating angles. We have 42 and here also 42 alternating interior angles. Then the opposite of BAC 42 and here 68. Then EB greater than EC, because EB opposite 68. Understood? You can find the relation between two sides by finding the relation between two angles first. And also we can divide this figure to two triangles. AC, draw AC. Okay? Then you can find the relation about left hand side and right hand side. You can read the solution about also example number 2 here. Number 2, you can read the answer. Okay? You can divide it or down. If you want to find the relation between angle A and C, you can draw line segment AC. And if you want to find the relation between B and D, draw line segment join between B and D. Okay? Next question, self-evaluation here. Number 1, the following figure give me AD parallel to BC. Okay, parallel to BC. We want to prove that AB greater than AC. Okay, listen to me about the steps to find the answer. Look, you can see here it will be 58 degree. We have alternating interior angles. Write the steps with me. You want to prove that AB greater than AC. Then you must prove that the opposite angle of AB, angle C greater than angle B. You must prove that. So you must first prove that angle A equal angle C and angle A here equal angle B, alternating interior angle. In the first step here, we can write such that EB or ED parallel to BC, and we have AB and AC are transversals of them. We have two transversals, AB and AC. AB, straight line AB, and AC are transversal. Of them. We have two transversal of them. Then measure of angle C will be equal measure of angle DAC, and measure of angle P equal measure of angle EAP. This angle EAP. The measure of angle C will be equal 58 degree, and measure of angle B equals 30 degree. And then measure of angle C will be greater than measure of angle P. Okay, measure of angle C greater than angle B. We have here 58 and here 30. Measure of angle B greater than, angle C greater than measure of angle B. Then in triangle APC, angle C greater than angle B, then the opposite of this angle AB will be greater than the opposite of angle C AC. The opposite of angle B AC. Then AB greater than AC. Okay, look at the question number 2 here. In the following figure, you want to prove that measure of angle ABE, exterior angle, greater than angle ACD. We know the relation between two supplementous angles. We have two supplementous angles here. First, he give me the relation between two sides. First, we have in triangle. Look at this. Look at, we have A, B, C triangle and A, D outside and also E. He want to prove that what? He want to prove that measure of angle ABE, this angle, greater than measure of angle ACD. And he give me the length of AB greater than EC. So first step, you can write in triangle ABC such that AB was greater than EC. AB greater than EC. Then the opposite angle here greater than measure of angle ACB greater than measure of angle ABC. And then we have 2 points pointing to straight line ED. Then two angles here, we call this supplementous. Then measure of angle ACD plus measure of angle ACE equal 180, or you can write such that angle ACD angle ACD supplementous angle ACP, and also angle ABE, this angle supplements also angle ABC. then we have the relation between angle C and angle B. Angle C greater than angle B, then supplementous of this angle, it will be less than supplementous of this angle. You write the inverse relation. Angle ACB greater than, then you can change direction here and write the supplementous of this angle. Supplementous ACB, where? Here. ACB supplementous ACD, then angle ACD. The supplementous about ACB, look, ACB, this angle, supplementous ACD, this supplementous angle. ACD, we can write the inverse direction about inequality. ACB greater than ABC, then the supplementous of this angle less than supplementous of the other angle. What's supplementous of ABC? ABC here, supplementous ABE. Then measure of angle ACD less than measure of angle ABE. Okay, because we have two angles here supplements and two angles here supplements, some of them 180, some of them 180. In supplement of the first angle, this less than supplementous of the other angle. You must know these properties to solve any properties in a triangle. Okay, this question number 2. Next question here. You can read the answer about question 1 and 2. Now example number 3, number 2, to solve evaluation number 2. Here he give me two triangles, or small and greater, and he want to prove that BD greater than CD. And he give me BD bisect and DC bisects angle C. The relation first between two sides, EB greater than EC, then the opposite angle C greater than angle B, then half of angle C greater than half of B. Then this angle C greater than angle B, then the opposite BD greater than CD. We can solve the relation also self-evaluation number 2 by this method. Look at here, we have triangle here, EBD and triangle ADC, and is the midpoint between B and C. He want to find or prove that measure of angle BAC is than 90 degree. He want to prove that BAC, this angle, less than 90. And he give me the relation also BC. Look at BC less than twice of AD. Okay. Then first step, look at with me about find the relation first between two sides. He give me BC less than twice AD. If we divide it by 2, then half BC less than AD. Half of BC, we have BC, half of this will be AD, then BD less than AD, and also half of BC will be DC, because D is the midpoint, then DC less than AD also. We have two relations in two triangles. We start to solve at this triangle first, such that in triangle ABD, this triangle, we have BD, look at here, BD less than AD. Now I write the relation between two sides in triangle. Look, BD less than AD. I will put this angle 1 and angle here 2. Listen, BD less than AD, then the opposite angle of BD 2, measure of angle 2, less than the opposite of side lines AD opposite angle 1, angle 2, less than measure of angle 1. Okay. And also in the other triangle, such that other triangle ADC, we have two angles also, here angle 3 and here angle 4. Okay, pay attention, this angle 3 and this angle 4. I found the relation here BD or DC was less than AD. The opposite of DC, angle 3, then measure of angle 3 less than measure of angle 4. this relation number 1 and this relation number 2. Okay, if we collect together 2 plus 3, it will be give me angle A, and 1 and 4 summation between together, it will be greater than the measure of angle A. We 8 from 1 and 2. We can collect left hand side by left hand side, right hand side by right hand side. The measure of angle 2 plus measure of angle 3 less than measure of angle 1 plus measure of angle 4. 2 and 3, it will be angle 1, measure of angle 1, meter angle A. We 8 together, 2 and 3 give me angle A. Less than summation between angle 1 and angle 4, C meaning less than measure of angle B plus measure of angle C. Okay, if we add angle A to left hand side, right hand side, then twice measure of angle A less than measure of angle B plus measure of angle C plus measure of angle A. What I do here? Who can tell me? I add angle here, A and angle A. Why? Because the sum of interior angle in a triangle equal 180. Then you can write then twice measure of angle A less than 180. 180 it's summation of any interior angle in a triangle. Understood? Twice angle A less than 180. We can divide it by 2. You know the steps. I add angle A to left hand side and right hand side. I add measure of angle A to left hand side and right hand side, here and here, twice A, and then the summation of 3 angles triangle 180 divided by 2, it will be 90. Then measure of angle A is less than 90. Measure of angle A less than 90. Measure of angle that he write BAC is less than 90 degree. Understood? Important question. Okay, next question down. You can read this example also. And question number 3, we have relation between two sides in triangle. We know some any two sides in triangle is greater than the third. You can read this example, okay? And you will solve question number 3 self-evaluation here. Okay, listen here. Give me triangle ABC, and he wants to find the values of x satisfies AC greater than BC. Okay, give me this information. In triangle, we have triangle ABC. This angle B and angle A. He give me AC greater than BC. AC greater than BC, then the measure of angle B will be greater than measure of angle A. So the measure of angle B he give me in this example here 50 plus x is greater than angle A was 60 minus x. We can solve this inequality. Move negative x here. X plus x equal 2x, and 60 minus 50 equal 10. Divided by 2, then x will be greater 5. X greater than 5. And also we have 60 minus x greater than 0. Then x greater than 60. And also 50 plus x greater than 0. X greater than negative 50. X greater than 5 and x greater than 60. We move x here. Move x here. We have 60 and x. Then x less than 60 and greater than 5 lies between 5 and 60. Then x is pointing to open interval from 5 to 60. Okay. Now we have new properties about inequality in two triangles. If two sides in triangles are equal lengths, corresponding sides to two sides in another triangle, and the measure of the included angles between the two sides different, then the greater angle in measure opposite to the longer side in the length. Okay, listen to me about this. I will explain here. Okay, listen. Look, if we have two triangles like this, A, B, C, and the other triangle C or D, M, N, we have two sides equivalent here, like DM equal AB and BC equal AM, and the included angle here were different. This angle B greater than angle M. Then the opposite side of the first triangle EC will greater than DN. Okay, you must know these properties in any triangle. Listen, he give me information here. We have two triangles here, ABC and EDF, and the relation between two angles here, angle A greater than angle B, the opposite side C greater than the opposite side EF. Also, if we have right angle triangle, then BT greater than EF greater than BC. Converse of the theorem: if two sides of triangle are equal in lengths to corresponding two sides in another triangle, and the lengths of the third side is different, then the longer side in length is opposite to angle with the greater measure, like this. Measure of angle here A will be greater than measure of angle D, because in two triangles we have two sides equivalent, AB equal DE and AC equal DF, and BC greater than EF, since the opposite angle A greater than angle D. Self-evolution number 4. You can read this example, it's easy, okay? Look, number 4 here, you can read this example and the solution. We'll solve self-evolution number 4 with you. Look at here, self-evolution number 4. Give me two triangles, the first right angle triangle and the other here this angle triangle. We have relation between two sides. Listen, such that in two triangles ACD and ECB, we have CD equal CB and EC is a common side. Then we have relation between two angles. Measure of angle ECD was 110 degree and measure of angle ECB was 90 degree. This angle was 90, and we have the difference relation between two angles. The measure of angle ACD will be greater than measure of angle ACB. In triangle EDC and triangle ACB, then we have relation between two angles in the other triangles, then the greater angle opposite the greater side in ED will be greater than AB. Okay, he won't compare between two lengths ED and AB. Next question, also number 2, the same idea. We have here in this triangle, look at here, we have two sides difference and two sides here difference. No, here 6. Okay, and DC is the common side between together. He will find the relation between angle ECP, AC, sorry, CDB, C, D, B is this angle, and angle ABD, ABD. You won't find the relation between two sides. First, we have DB, is the common side. You know, we have two sides in first equal two sides in second. DB is the common side. Listen, we can draw this first triangle like this. DB is the common side, such that in two triangles we have C and A and D here. such that in two triangles DCB and DAB, we have DB is a common side. DB is a common side, and we have two sides are equal. We have C 9 centimeter and 9 centimeter. AB equal DC equal 9 centimeter. Then the relation between other sides give me the opposite angles difference is a measure. We have BC was 5, such that BC less than AD was 6 centimeter. 6 centimeter AB. Then the opposite angle of the first is greater opposite angle in the other triangle, because 6 greater than 5. In the opposite of 6, this angle ADB, measure of angle ABD, will be greater than measure of angle CDB. Okay, understood? It's an easy question. Okay, next down. Example number 5. Find set of possible values for x in each of the following. Listen, we have two questions. Question number 1 and 2. You want to find the relation between x and here. About sides, we have AD equal AB and AC is a common side. Then we have the difference between two angles. X minus 9 is less than 25 because 7 greater than 6, the opposite angle here, 25 is greater than. You can raise the relation, and also the measure of angle greater than 0. You can find x between two relation, intersection between together. And here also you can read this question. We have two sides equivalent and two angles between are equals, and two sides we have 65 and here 56. Okay, we have the difference angles and the opposite 12 centimeter greater than 4x minus 12, and we know also 4x minus 12 is greater than 0. Now I will explain left hand side here. This question number 5, self-evaluation number 5. Listen to me about the steps. Here in this question you want to find the value of x. First, we have in two triangles the proof here. Okay, in two triangles ACD and the other triangle BCE. We have CD was equal to CB, and EC is the common side. This is a common side. Then we have relation between two angles in the first second, such that measure of angle ECD was 120 degree and measure of angle ACB was equal 90 degree. This angle greater than angle ACB. Measure of angle ECD greater than measure of angle ACB. Okay, then the opposite side of this angle, x plus 9, look at here, x plus 9 will be greater than 2x minus 6. We can move x here, 2x minus x equal x, and negative 6 to positive 9 plus 6 is 15. Then x less than 15. This is relation number 1. And we have also x plus 9 greater than 0, x greater than negative 9. And 2x minus 6 must be greater than 0. In any triangle, the side length must be greater than 0, not negative, okay? Then 2x greater than 6, you can divide it by 2, then x greater than 3. Relation number 2. Then x lies between 3 and 15. Okay, then x will be belonging to the open interval from 3 to 15. 3 to 15. Okay, this is solution about this question. Next example down. Give evaluation number 5. It's easy question. Okay. Next question down here, lesson assessment. Okay, arrange ascending order and measure angle each of the following. Look, we have here 18, 14, 21. What is the greatest? The greatest will be 21. Then the opposite angle C will be the measure of it greater than measure of angle C greater than angle 1 C, and then 18 opposite to A greater than angle A greater than, we have 14 centimeter EC opposite angle B. Okay, this is question number 1. Next, question number 2. We have 106 centimeter and we have 2x and x, then ED is a greater side because we have obtuse triangle. In the opposite side, FD will be the longest side, and then FE and then DE. Okay. Question number 3. We have also here hypotenuse SCT is the greater sides. Opposite 6T. Then we have SCT is the greater sides, and then S, he want to arrange the measure of angles. Okay, again about question here, he want to arrange the angles. Okay, I will solve question number 2 again. We have the F greater than FE greater than DE. DF opposite to angle E. The measure of angle E is the first. And then 2x opposite D. 2x opposite D, right? D. Measure of angle is greater than DE opposite angle F. Measure of angle F. Okay. Next question. Look at this question. We have ST is the hypotenuse, then the measure of angle B is the greater angle. And we have 6 opposite T greater than measure of angle T, and 4 opposite S, measure of angle S. Then B greater than T, T greater than S. Arrange in ascending order side. Ascending from smallest to greatest. First step, we can find the measure of first angle here, angle C. In this triangle, we know the sum of interior angle triangle 180. We can write 180 subtract by the sum of two angles, 34 and 58. Third angle here, 79. Then the greater, he wants to arrange the order sides in each of the following. The sides. Okay, the smallest will be 43. 43 greater than opposite CP. Okay, this is less than, and 58 less opposite to AC. Opposite to AC, right? AC. And then AC less than, measure of angle C is the last one opposite to AB. Understood? CB, AC, AP. This is question number 1. Question number 2. We have angle 100 and he wants to arrange ascending. First step, we can find the third angle 108 subtract sum of 47 and 100. The third angle will be 33. This angle 33. We have 133 and 47. Okay. The smallest side will be down here DE, less than this side opposite 47 FD, less than FE. We arrange here ascending order, and this also we want to arrange the sides ascending. Look at X opposite to TP, then TP less than 2X opposite to SP. SB less than ST. ST is a hypotenuse in this triangle. Next example. compare between two required measure below figure. The length of FD and the length of CB. We want compare between two sides. FD, look at here, this side length, and also side length CB. First step, we can find the measure of angle A here. Write 180, subtract some interior angle, 40 plus 30, 70, subtract from 180, it will be 110 degree. Then we have relation between angle A and angle E. Angle E was 100 and angle E 110. Then the opposite side of 110 is greater than 110, measure of angle A, then CB is greater than the opposite of 100, it will be FD. Okay, because we have two sides equivalent in the length and the first triangle, this side equals this side and this side equals this side, and we have difference between two angles, then the greater angle opposite the greater sides, and the small side here will be FD. Next question, also we have two triangles here. We have BC equal to AP. DC was equal to AP equal 5 centimeter, and we have also DB is the common side. DB is the common side here. Then we have the relation between two other sides. Look at here, 3 greater than 4. BC was greater than, BC less than AD, because BC 3 centimeter and AD 4 centimeter. In the opposite angle of BA, look at here, we have BC less than. See here, opposite to this angle, angle D. The measure of opposite angle of BC, it will be measure of angle CDB. CDB less than, we have ED, opposite of this angle ABD. Measure of angle EBD. Okay, then measure of angle CDB less than measure of angle ADB. Next question, number 3. You won't find the length of AP and the length of BC, the relation between together. We have here supplements of this angle 70. We have BD is the common side. BD into triangle, BD is the common side. In triangle, we have common side. And also DC equal to AB, AD. Okay, we have two sides here equivalent. And measure of angle ADB ADB greater than measure of angle ADC, because this angle supplements of it 110 greater than 70. In the opposite side, AB will be greater than the opposite side of angle 70 BC. Understood? Next question. Find the possible values of x that satisfies the condition below each one. First, measure of angle A greater than angle B. Angle A greater than angle B, then the opposite side x will be greater than the opposite side of angle B, AC, greater than AC. Then x greater than 3, and also x must be equal 0. Greater than 0. Okay, then x greater than 0 and greater than 3. So the result from x 3 to infinity, we have 0 here to infinity and 3 to infinity. The intersection from 3 to infinity. Solution set, or x, look at here, x is pointing to the open interval from 0 to 3. Listen, question number 2. We have TB greater than ST. TB opposite what? TB opposite to x. Then x greater than opposite of ST, it will be angle 50. x greater than 50, then x greater than 0, and from greater than 0 and greater than 50, it's meaning x belonging to open interval from 50 to infinity. Lesson number 3. He give me AD greater than AB. AD, look, AD x greater than AB. AB was 7. X greater than 7. From 7 to infinity, because we have two sides equivalent, and he will find the value of x. Then x belonging to open interval from 7 to infinity. Next question, applying concepts. Second, in each of two following figures, arrange sides of triangle ABC. We can arrange the sides here, from smallest to greatest. The first triangle, we have 3 angles. We can find the measure of x first by 3 angles, sum of any interior triangles, any triangle equal 180. First step, we can write 4x subtract by 12 plus 3x plus 17 plus 2x plus 13. The result will be 180. 4x plus 3x, 7x, 7 plus 2 is 9, 9x. Negative 12 plus 7, 5, 5 plus 13 equal 18, is 180. Then 9x equal 180 subtract by 18. 10 minus 8 equal 2, 7 minus 1 equals 6, and write 1. Okay, write 162 divided by 9 equal 18. Then x will be 18. Now we can find the measure of 3 angles here. Look at here, we have triangle. I will put the value of x equal 18 about the first angle here. I will find first angle C. Look, angle C, the measure was 2x, 2 times 18 plus 13. The result will be 49. And then measure of angle A, 3x plus 17, 3 times 18 plus 17 equal to 71. And the third angle here, 180 subtract some interior angle. 180 subtract by 71 plus 49. The result will be 60 degree. This angle B. Now I will arrange. He want to arrange what? Arrange the side. Okay. Then I will write the relation between two angles first. We have 71, measure of angle A greater than measure of angle B greater than measure of angle C. Then A opposite to BC, and angle B opposite to AC, and angle C opposite to AB. Okay, this is question number 1. Question number 2, we want to arrange the side of triangle ABC here. Listen, we have right angle triangle, and its straight line bisect to AC, and we have B and D. First, we know EC is the hypotenuse is this triangle. He want to arrange the sides in triangle ABC. This triangle, the sides here. EC is the hypotenuse here. Okay, then EC is the longest side. We have angle here exterior. This angle exterior of this triangle, this angle greater than angle A. Understood? And AD is the hypotenuse also, greater than AB, and AC greater than AB. Look, about C, AD is hypotenuse. Okay, and we have right this hypotenuse greater than this hypotenuse. Then EC is the first side, greater than what? We have relation between BC and AB. AB will be greater than BC. AB greater than, because this angle is exterior about here, and two angles equivalent. Two angles here are equivalent the measure. angle C greater than half of this angle, exterior angle, and also this exterior angle greater than here, and this angle greater than this angle. Look, like I will put here angle 1 and angle 2. Measure of angle 1 greater than measure of angle 2, because this obtuse angle and here acute angle. The opposite of angle 2, it will be AB. Okay, greater than the opposite, we have angle 1 greater opposite than AD is greater than the opposite angle to AB. AD greater than AB. He want a range ABC, then AC, the hypotenuse, greater than AB, and AB greater than BC. It's easy, okay? Why we do that? Because he want to find the result, or I write the answer by steps, or proof. Like measure of angle 1 greater angle 2, 2 greater than this angle, and 1 greater than this angle, 1 greater than. They are equivalent. Angle A greater than half of this angle. If you want a range about the greater side, then AD greater than 2, BD greater than AB. But in the small triangle ABC, we have EC is hypotenuse greater than EB greater than BC. Next question, number 6. Given figure, he want prove that measure of angle C greater than measure of angle B. He want to prove that angle C greater than angle B. We have ED is the line segment midpoint here. He give me the relation between ED and EE. Look, we have here triangle. Two sides are equivalent here. No. Two sides are equivalent, and this in the middle. And we have relation about two sides, EE and here AD, and we have C and B, such that in triangle EDE, this triangle ADE, we have ED is greater than EE, ED greater than EE, this side length greater than this side length. The measure of angle E greater than measure of angle E greater than measure of angle D. Okay, we have two sides parallel, DE parallel to BC, and we have two intervals here. We have AC and EC straight line and EB straight line are transversal. They are transversals about two sides here. Look at here. We must prove also DA parallel to BC. I want to prove first, such that E and D are the midpoints of EC and EB, then DA parallel to BC. You must prove this first. Okay, before these steps you can write such that E and D are midpoint of, we have E, the midpoint of EC and AB. They are the midpoints about EB and AC, and we have two transversal here. Then measure of angle E equal measure of angle C, and the measure of angle D equal measure of angle B. We called it what? Corresponding angles. Right here, corresponding angles. They are equivalent. This relation number 1. This relation number 1. And or this one, he give me AD. This number 1. Okay, this relation number 1, and this relation number 2. From 1 and 2, look at here. E is greater than angle D, and E equal C and D equal B. Then measure of angle C greater angle B. Then, or from here, from relation number 1 and 2, then measure of angle C is greater than measure of angle B. Okay, Understood? Next example here, we have also same idea. Look, we have AC greater than AB. Look at here, we have two triangles, first and second, like this. ACB, and we have DFE. They are parallel here, and this parallel this, such that in triangle ABC we have AC less than AB. Then the opposite angle of AC, angle B, is greater than the opposite of side AB, angle C, greater than angle C. This is relation number 1. We have here two sides parallel, such that AC parallel to DF, and we have straight line BC is transversal of them. This transversal, then we have two angles equivalent. Then measure of angle C equivalent to measure of angle F, we called it corresponding angles. And also we can parallel here, such that DE parallel to AB, and we have this straight line transversal of them, BE, is transversal of them. The measure of angle E will be equal measure of angle B, measure of angle B. This relation here number 2, and this relation number 3. Look at here, angle B greater than C, E and B equivalent, and C and F equivalent. The measure of angle E greater than measure of angle F. From relation 1, 2, and 3, from 1, 2, and 3, then you can write measure of angle E will be greater than measure of angle F in triangle DEF. Then DF or DE, he wants to prove that DE greater than DF. DE, look at here again, he give me the information EC less than, yes, EC less than, not greater than. Again, AC less than AB. Okay, I change direction. Again, AC less than AB. The measure of angle B less than measure of angle C. Okay. Then from relation 1 and 2 and 3, look at here again. Measure of angle B less than angle C. B equal E and F equal C. The measure of angle F greater than measure of angle E. E less than F. E less than F. F opposite to ED. Then ED will be greater than the opposite of angle EDF. Then DE or ED greater than DF. Understood? Again, my students, understood. First step, you must know EC was less than, not greater than. EC less than AB. Then the opposite angle here about AB greater than this, greater than angle B. And we have two corresponding angles, two corresponding angle equivalent. C equal F, E equal B. C greater than B, then F greater than E, then opposite side here DE greater than the opposite angle here DF. Okay. Next question. Question number 8. In the given figure, give me here isosceles triangle B equal AC, such that in triangle ABC, we have AB equal AC. Then measure of angle B will be equal to measure of angle C. They are equivalent. We have isosceles triangle here. This relation number 1. And also, he give me the relation between two angles ECD. Here is this angle, such as that. Measure of angle ECD is greater than measure of angle ABD. ECD greater than ATB. This relation number 2. We can find the difference between two relation here. He won't find the relation between DC and BD. Right, from relation number 1 and 2, we have here a isosceles triangle. This angle equal this angle. They are equivalent. And give me the relation between two angles. ACD, this angle, is greater than, we have ACD, this angle ACD greater than ABD, greater than this. Then the remainder here will be also greater than. You want to prove that DC greater than DB. Then look it again. This angle greater than this angle. Then the remainder here about first angle, remainder here less than this angle or greater than this angle. Then the remainder here less than this angle will be less than this angle. From relation 1 and 2, we can find the inverse. Look, if we have two angles equivalent, like if I put this angle 50 and this angle 50, maybe 50, and I will give you this angle 40 and this angle 10, then the remainder here will be 10 and the remainder 40. Then the remainder about greater angle will be less than the remainder of a smaller angle. Okay, you must know the steps. So again, we have angle C equal angle B, and this angle ACD, okay, this angle greater than this angle. Then the remainder here about first, it will be what? It will be less than the remainder of a smaller angle. The smaller, and this greater and this smaller. Then the remainder here, it will be less than the remainder here. Okay, then measure of angle DCB less than measure of angle DBC. DBC. Okay, my students, understood? Again? Okay, again. I will explain it again to understood. Okay, listen, I will draw big triangle like this. We have isosceles. They are equivalent. Angle C equal angle B. They are equivalent. I will draw like this. And I will tell you this angle is greater than this angle. Then the remainder here less than the remainder here. This angle, look, angle ACD greater than angle ABD. Then the remainder about first less than the remainder about second. Again, look at the inverse. This angle greater than this angle. Then this angle less than this angle. Okay. Then measure of angle DCB less than measure of angle DBC in triangle DBC. Then the opposite of this side, it will be DC. Then DC greater than the opposite of this angle DB. The opposite here, DC greater than DB. Understood? Okay, next question, number 9. We have parallelogram here. We want to prove that measure of angle EMB greater than measure of angle CMB. I will draw here a parallelogram. We have parallelogram. A, B, C, D. A, B, C, and D parallelogram. Okay. We know in any parallelogram two diagonals bisect each other. He give me AB greater than BC. Look, AB greater than BC. In this angle we call it 1 and here 2. AB greater than BC, then measure of angle 1 greater than angle 2. And we have angle 3 and angle 4. This also one angle 3 greater than angle 4 because the diagonal bisects the vertex. He want to prove that AMB, this angle, greater than angle CMB. Greater than this angle is greater than CMB. Okay, we can find the relation about two triangles such that in parallelogram in ABCD, the parallelogram, we have MC equal to MA, and in two triangles BCM and the other triangle BMA, we have two sides equivalent here. MC was equal to MA, and MB is the common side. Okay, MB is the common side. MB is the common side. Okay, MB is the common side between together. Then we have relation also between two angles. He give me measure, or he give me EB. Look, he give me this relation EB greater than BC. Look at here, I will write here. Look, he give me this relation EB, this side length greater than BC. Then measure of angle 1, it will be greater than measure of angle 2. Angle 1 greater than angle 2. Okay, and he want to prove that measure of angle AMB, this greater than measure of angle CMB. Okay, EB greater than BC. Cancel 1 and 2. We have in two triangles the opposite. I will solve now in two triangles, okay, not one triangle. If I give you this 1 and 2, ask it about angle 1 and 2 greater than in this triangle, but I now find the relation between two angles in two triangles. He give me AB greater than BC, and we have relation between two triangles here, such that EB greater than BC is in the opposite angle here. Measure of angle AMB is greater than the opposite angle of BC, it will be CMB. Okay, again my students, if we have two triangles similar about two sides and the third side common between together, two sides in the first equal two sides in the second, then we have relation between two other sides. If two other sides is difference and the length is in the opposite of greater side, give me the greater angle. The greater angle here, the measure of angle AMB greater than measure of angle CMB, because EB greater than BC in the opposite angle of EB greater than the opposite angle of CBC, then the measure of angle AMB greater than measure of angle CMB. Okay, understood? But don't find the relation between angle C and A in the biggest triangle. I want relation between two triangles only. Find the values of x here in this expression about. In this triangle, we have two triangles here. First, we have two sides are equivalent. ED was equal to BA, and FE equal to CB. Okay, then the first side 3x minus 12 opposite to 30. We have relation between two angles. Measure of angle B less than measure of angle E. This 30 and this 45. In the opposite in triangle, two triangles here, ACP, and the other triangle FED or AFD. We have relation between two angles and two sides equivalent the first and second. Then measure of angle B opposite to measure of angle B 30 opposite to AC. less than measure of angle A opposite to FD. Then EC was 3x subtract by 12 less than FD was 6. Solve this inequality. Move negative 12 here. 6 plus 12 equal 18 divided by 3, then x less than 6. And also we must know any sides in a triangle must be greater than 0, then 3x greater than 12, then x greater than 4, then x less than 6, and greater less than 6 here, and greater than 4, like this part. Then x will be belonging to the open interval from 4 to 6. Okay, next question, number 2. We have here two triangles. The relation also we have BC, look at here, BC equivalent to CD, and AC is a common side. Okay, is a common side between two triangles, and two triangles BCA and CAD. We have the relation between two angles here and two sides. First, ED was greater than AB. That's 30 centimeter and here 18 centimeters. Then the opposite angle of 30 will be 72. Greater than the opposite angle of 18, 4x minus 24. This angle, 4x minus 24. We can move 24. We have 72 plus 24 greater than 4x. 7 plus 2 is 9, and 7 plus 2 is 9. Okay, write this what? We have 72 is greater than 4x minus 24. Okay. Okay, 72 open 30 and this open 18. Okay, move 24 here, then 72 plus 24 greater than 4x. 4 plus 2 6, 2 plus 7 is 9 divided by 4. 9 divided by 4 equal 2, and the remainder 1. 16 divided by 4 equal 4. And we must know also 4x minus 24 is greater than 0. Then 4x greater than 24, because inside a triangle must be greater than 0. If we divide it by 4, 24 divided by 4 equals 6. We have 6 and 24. X greater than 6 and x less than 24. Then x belonging to the open interval from 6 to 24. Okay. Analyze and subject integration. Look at here. The ancient Egypt used the opposite tool. Look at here. Use the tool to smooth and shape wooden pieces. Which of two angles A and which of the angle formed blade of the tool with handle? Angle B, which is the angle formed by the blade to the tool with the work surface, and explain how. We have relation between three sides. Look at here, 6.8, and we have 4.5 and 5.5. Then we can find the relation between two sides in triangle. We can write in triangle ABC. We have the different sides. Then you can start by the grid side CA greater than 5.5, CP greater than AB. In the measure of opposite angle, CA opposite angle B is greater than measure of angle CB opposite to A greater than AB greater than angle C, measure of angle C. Okay. Okay, he wants to find the relation between angle B and angle A. Then the measure of angle B greater than measure of angle A, which is the angle formed by the blade of the tool with work surface, measure of angle B, because measure of angle B is greater than measure of angle A. solution, measure of angle B, this angle greater than measure of angle C. Okay, my students, then I can write the steps. We can write this the largest. You won't explain, okay? We can write the largest side is CA, so the opposite angle B is the largest. Okay, because you won't explain the steps. Look at next question. This question, he wants, look at here, you want what? Two roots. Give me two roots here. Two roots meet a line at angle measure 50, intersection at 50, point A. Okay, a third root from B to C makes an angle measure 45 with the root from A to C. Which of the two intersection A or B is closer to C? Which is closer to C? We know 45 opposite to AB and measure of angle A opposite to BC. In BC greater than AB, he won't find the closer to C. The closer to C what? From A or B. A or B closer to C, we can find the lengths with the third. Look at here, we have triangle A, B, and C. Look, we have 50 and 45, 180, equal 85. Then AC will be greater than the opposite of 50, BC greater than the opposite of 45, EB. Which of two intersection, A or B closer to C? Which is closer to C, A or B? We have the closer, it will be the small sides from B to C. B nearest to, because this angle 50 measure of angle A less than measure of angle B, then A opposite to BC less than B opposite to AC, then BC less than AC, BC less than AC. He won't find the closer. The closer will be what? From intersection A or B, intersection from A. The closer from A. Okay, the intersection from A closer to C. The intersection from A, the intersection from A is closer to C. Understood? We have 50 opposite BC and 85 opposite to AC. Then the intersection from this side, which this side here closer to, from B, because this line segment BC, look at here, BC less than AC, it's more, but B, the intersection from B is closer to C. Intersection from B. Understood, my students? Look at here, this line segment opened 50 and this line segment opened, then AC greater than BC, then the closer to C, BC, because this side the small, this side smaller than this side, BC less than EC, BC less than EC, then the closer to C from B to C. Okay, like this. It's clear now. Okay, from B, the section B to C, it's closer. B nearest to C, but A is a longer distance. Creative thinking. In the opposite figure, we have ABC right angle triangle and BD bisect AD bisect angle A. He want to prove that BC greater than BD. He want to prove that BC greater than BD here. Okay, we want to find the relation between two opposite angles. We have two triangles. We have right angle triangle here. This obtuse angle EDC greater than angle B, then EC greater than AD in this triangle. And we have also exterior angle. If you want relation between DC and DB, we have relation between two sides. We have ED bisects the angle D in two angles equivalent in the measure. Okay, think with me about this question. Look, first step, I will draw a triangle here, right angle triangle, like this, and ED. I will draw this line segment perpendicular. Do here DF. We have B and C, and here F. I will draw DF perpendicular to AC, and we have two angles equivalent here. Then we can prove that two triangles are congruent. I will draw, then first step, draw DF perpendicular to AC. Then in two triangles ADF and ADB, we have AD is the common side. Is a common side. We have AD is a common side. Measure of angle D equal measure of angle F. D equal angle F. AD is a common side. A measure of angle F equal measure of angle B equal 90 degree. They are equivalent in the measure. Then two triangle will be congruent. Then triangle ADF will be congruent triangle ADB. They are congruent. Then this line segment equal line segment. Then DF equal DB. And then in this triangle, small triangle here, in this relation number 1. Okay, we can work at this triangle. In triangle FDC, we have DC is greater than DF hypotenuse. We have DC hypotenuse triangles in DC greater than DF is relation number 2. Okay, it's relation number 2. From 1 and 2, look, DC greater than DF and DF equal to DB, then DC will be greater than DB. Okay, greater than DB. Solution about this question. It's important. Next question. Okay, it's last question. Thank you, my students. You must understood all questions. Goodbye.